So now that we have gone through all of this organic chemistry and all of these compounds, I'm pretty sure some of you would be asking, why are we doing all of this? And why do we need to know about all of this? We need to know about these compounds because of two main contributions. The very obvious one is the VOC, the volatile organic compound. While the VOC on its own is not really in the NACs, so we are regulating the ozone, not the VOC. However, the VOC is a precursor of NACs, of ozone, and if you control the VOC, you are controlling the ozone. So therefore, we need to know our VOCs. Again, what are VOCs? VOCs are volatile organic compounds that partition between the two phases. Some of them will be in the gas, some of them will be in the liquid, or even the solid. So knowing what we know now, we can learn much more about VOCs, and we can at least understand the most important ones, the one that occur very frequently. Also, another list that we need to learn about is the HAPs. I will explain that. HAP stands for hazardous air pollutants. I will explain that in a second. So look with me here. I will share my screen just a second about the EPA definition of VOC. So in this definition over here, the volatile organic compound is any chemical substance which contains compounds of carbon, excluding carbon monoxide, carbon dioxide, carbonic acid, metallic carbides, or carbonates, ammonium carbonate, determined to have photochemical reactivity. So the EPA definition of VOC is a little bit different than the definition that any scientist will use. Scientists will only say the VOC is whatever partitions, because it's volatile. That's what the definition of VOC is. The EPA definition is not only that it is volatile, but it has photochemical reactive part, because it needs to be responsible for the development of ozone. That's where we draw the line. Is it contributing to the formation of ozone? Then it's a VOC. If it's not, then it's not a VOC. Let's look at the list of things that include. They include determined to have negligible photochemical, which have been determined to have negligible photochemical: methane, ethane, methylene chloride, 1,1-trichloroethane, 1,1,2-trifluoroethane, and the list keeps going forward. I'm pretty sure that now you started to say, okay, so we really looked at some of these in the other presentation, so now at least you get sense of what causes ozone using the photochemical reaction. Now, the other reason that I told you that we need also to understand organic chemistry, not only because of VOC, but because of another list of compounds where it's called HAPs, hazardous air pollutants. Now, hazardous air pollutants are regulated not because they cause ozone, but because they are hazardous on themselves. Basically, because they can cause cancer. So this list includes 189 pollutants. Not all of them are organic, but most of them are, including acetaldehyde that we talked about, acetamide, acetonitrile, acetophenol, acrolein, acrylamide, acrylic acid, and the list keeps going on. Some of them are metals, such as lead that will be here, but chloroform, a lot of ocresol, mcresol, a lot of compounds that we talked about are on the list of the 187 HAPs that are actually much more regulated than the VOCs. The limits for regulation are much lower. So now we have a really deep window into VOCs and HAPs, knowing our organic chemistry that we got to know now. Thank you for listening, and good luck for all of you.